Interfacing LM35 temperature sensor with ARM Cortex-M4 microcontroller. In this video, we will interface LM35 temperature sensor with ARM Cortex-M4 microcontroller available on TM4C series launchpad. LM35 is a precision integrated circuit temperature sensor whose output voltage varies based on the temperature around it. Since the output of the temperature sensor is analog voltage, therefore we will be using the ADC module of the microcontroller. So let's start. These are the steps that we will be following in this video for interfacing the LM35 temperature sensor. First of all, we will discuss an example program involving the LM35 temperature sensor. After that, we will select GPIO pins for digital output as well as analog input. These pin selection will be followed by the GPIO configurations, and after that we will see the ADC module configurations. We will also see the pinouts for the circuit connections and the circuit diagram of the application. At the end of the video, we will write a C language program in Microvision Keil IDE, and I will also show a live demonstration of the example program. So let's get started. As a case study, we will take this example program in which we will interface LM35 temperature sensor with TM4C series launchpad evaluation board, and we will program it to display the room temperature value on a 4-digit common anode 7-segment display. In this video, we will see how we can interface the LM35 temperature sensor as well as the 4-digit common anode 7-segment display, and all those configuration steps and programming steps. The first step is to select the GPIO pins for interfacing the 7-segment display. We will see its pin out diagram later, but for interfacing the 7-segment display, we will be using the entire port P in order to interface the different segments from segment A to decimal point. For the selection of the digits of the 4-digit 7-segment display, we will be using the port A, pin 2 to pin 5. Now let's see which analog pin we can use for interfacing the temperature sensor. As we know, there are 12 analog input channels available on TM4C series launchpad microcontroller. We can use any one of these. Let's use analog input channel 1 that is multiplexed to GPIO port E pin 2. After finalizing the GPIO pins, the first step is to enable the clock. The clock getting control register is used to enable the clock on different GPIO ports. Its bit 0 to bit 5 can be used to enable the clock for port A to port F. Since we need to use the port A, port B and port E, therefore we will be enabling all these 3 bits in the register. So the corresponding value that need to be written on this register is hex 13. After enabling the clock, next we need to perform the bus selection step. As we know that every GPIO port can be accessed by advanced peripheral bus as well as advanced high performance bus. Let's choose the advanced peripheral bus for the port A, B and E for our example application. So the corresponding base addresses has been written over here. We will need these base addresses for calculating the address of different configuration registers of these ports. Let's discuss the configurations of each port separately. First of all, we will see the configuration steps for the port B, where this different segments of the 7-segment display has been interfaced. So this is the base address for the port B, and since we are using all the pins, therefore the mask for this port will be hex FF. In the step 3, Uh, in the step 3, we will disable the alternate function select by writing the value 00, and in the step 4, we will digitally enable the entire port by writing the hex FF. Also in GPIO direction register, we will set all the bits in order to configure them as an output. And the last register that is used to write the value as an output, we need to calculate its offset value. Since we are using all the bits from bit 0 to bit 7, therefore its offset value will be hex 3FC. And the corresponding register address is calculated by adding this offset value to the base address of the port P. Also, the addresses of the remaining registers is calculated in the similar fashion. Same steps has been performed for the port A, as it is also used as digital output for interfacing the digit selection. But we are only using pin 2 to pin 5, therefore the only difference is that now we are enabling only pin 2 to pin 5, and we are also setting pin 2 to 5 as a digital output pin. Also in the data register, we can calculate the offset only for these 4 pins, or we can calculate it as the entire port, and in the code we can use different bitwise operator to access the different pins. For interfacing the LM35 temperature sensor, we are using the port E pin 2. Since we want to use this pin as an analog input pin, therefore first of all we need to disable its digital functionality by clearing the corresponding pin in the GPIO digital enable register. Also, we need to set the corresponding pin in the analog mode select register so that we can use this pin as an analog input. Now these are the configuration steps related to the ADC module. The first step will be to enable the clock on this ADC module that can be achieved by writing hex 01 to the clock getting cycle register related to the ADC. In the second step, we are configuring 250 kilosamples per second by writing the value hex 03. Also in the step 3, we are not using any triggering source, we are just using the continuous sampling on the sample sequencer 3 by writing this value. In the step 4, we don't need any sequencer priority because we are just using a single sequencer. In the step 5, we are using the averaging over 16 samples, and for that we need to write the hex 04 value to the sample averaging control register. In the step 6 ADC control register, we are not using this register for configuring the voltage reference. By default, the internal VCC is used as a voltage reference for the VCC, which is 3.3 volt. In the step 7, we will be using this register in order to activate the sample sequencer 3 available on the module ADC module 0. And there is no need to use the step 8 as we are not using any triggering source, therefore we don't need to write to any ADC triggering registers. So these are the configuration related to the ADC module. Now we will see some of the configurations related to the sample sequencer. Since we are using the ADC module 0, whose base address is written over here, the second step of the sample sequencer is to select the analog input channel. Since we are using the analog input channel 1 that is multiplexed on port E pin 2, so therefore we need to write the hex 01 to the sample sequencer 3 analog input selection register. As we discussed in the previous video, that we always need to specify the end of sequence for a sample sequencer. Since we are using just one analog input channel, therefore we also need to specify the same input channel as this end of sequence by writing hex 02 in the sample sequencer 3 control register. So after the conversion of the analog input channel available on the sample sequencer 3, the ADC result will be available in the ADC sample sequencer 3 FIFO data register. So in order to read those ADC conversion results, we need to read this register that we will implement in our C language code. So these were some of the configuration registers that were important for a sample sequencer configurations. This slide shows the different pinouts of the peripherals and the microcontroller for circuit connections. As you can see, the 4-digit 7-segment display has total 6 pinouts. The 8 pinouts are related to the different 8 segments of the display, and the 4 pins are related to the digits of the 7-segment display. Also, the LM35 temperature sensor has 3 pin outs, just like a normal transistor. The first pin is the VCC that we will be providing from the TM4C series launchpad, and the third pin is the ground. The middle pin is the analog output, and it has a sensitivity of 10 millivolts for a 1 degree change in the temperature of the surrounding. On the left side, I have highlighted all the pins that we will be using for interfacing the 7-segment display as well as the temperature sensor. I have shown all these connections for the top side of the board. On the bottom side of the TM4C series launchpad, we have the female connectors that can also be used for connecting these peripherals. The circuit diagram of the temperature measurement system has been shown over here. One important thing to note is that in order to trigger these 4 digits, we are using a buffer circuit. This buffer circuit consists of a BC558 PNP transistor, and we are using emitter and base resistances to limit the amount of current. The normal value for the resistance attached to the emitter is 330 ohm, and for the base we can use 470 ohm resistance. You can also notice all the segment LEDs has been connected to the port B pin 0 to pin 7, and as discussed earlier, the LM35 temperature sensor's analog output is connected to the port E pin 2. So this is the circuit diagram of the whole project, and you need to connect all your peripheral according to this diagram. Now let's discuss the calculation step for the temperature value. These calculation steps depends on both the temperature sensor as well as the TM4C123 microcontroller. LM35 temperature sensor is a linear sensor that has a scaling factor of 10 millivolts per degree centigrade. And the TM4C123 microcontroller has the ADC that is 12-bit. And if we are using the internal voltage reference, which is 3.3 volt, then the ADC resolution will be 3.3 divided by 49,600. So manipulating these two results, the temperature out can be calculated by using this formula. In our C language program, we will be implementing this formula for calculating the temperature. Now we will write a C language program for the temperature measurement in Microvision Keil by using Microvision Keil's project manager. Now let's write a C language program using the project manager of Microvision Keil. Select the new Microvision project and specify the directory. Always create a new folder for creating the project, and let me call it temperature measurement. So the project name is temperature measurement. In the select device for target, type the device name, which is TM4C123GH6PM. Select this device, hit OK. In the manage runtime environment, we need to select the core from CMSys, and from the device we need to select the startup file. Hit OK. So the blank project has been created. Let me change the target to TM4C123 GH6PM. In the source group, we can add a new file by right clicking on source group 1 and select the add new item to group. So we have a bunch of options. Since we are trying to write the C language program, therefore select the C file and type the file name. Let me call it LM35 interfacing. Hit add, and you can notice a new C file has been added to the project, and it is open in the text editor. Now we can start writing C language program. Let's now discuss the C language program. At the start of the file, I have added the comments that specify how program will work and also shows the details for the interfacing of the 7-segment display and temperature sensor. After that, the program starts by defining some macros that are required to define the registers and their values. As you can see, the first of all, I have defined the macro for the clock getting control register for GPIO ports, port A, B, and E. Then the macros related to the port A configuration registers has been defined, to which the 7-segment displays digit 1 to digit 4 is interfaced. Next, I have defined uh, the macros for the port B, to which the 8 segments of the 7-segment display are connected. Similarly, for the port E, macros has been defined, to which the LM35 temperature sensor is interfaced. Next are the macros defined for the ADC. As you can see, the first I have defined the macros for the clock getting control for the ADC module. Then some of the registers are related to the ADC module configuration. And next I have defined the registers for the sample sequencer 3 configuration registers. Next are some macros defined related to the clock frequency of the microcontroller that are required for generating delays. After that, you can find a function prototype. This function is used to generate delays in the program. Next is the global variable declaration. The first variable is an array that serves as a lookup table in order to show different digits on the 7-segment display. It is very important to note that this 7-segment display's lookup table is designed for common anode configuration of the 7-segment. Similarly, the storing 4 digits, I have also defined an array, and this last variable is the value of the temperature that we want to calculate. In the main function, you can see there are some local variables, and I have applied all those configuration steps. Initially, the clock is applied to the GPIO port, and there is 3 clock cycle delay. And after that, the port A and port B a configuration has been applied. The next, you can see that the port E pin 2 has been initialized as an analog input channel. Next, you can observe the sampling rate has been defined, and the sampling rate has been defined, and the triggering source is set as a continuous sampling on sample sequencer 3. Since we are using single sample, therefore no sequencer priority is set, but we are averaging over 16 samples, and we are using the internal voltage, so therefore no voltage reference therefore no need to select any voltage reference. After that, we are setting the sample sequencer 3 as the active sample sequencer, and specifying the analog input channel 1 as the uh, channel assigned to the sample sequencer 3. And in the last configuration, we are specifying the current analog input as the end of sequence. So these are the configuration steps. After that, you can see while loop has started. It means the code inside this while loop will execute forever. So at the start, I have given a small delay, and you can notice after the delay, I am directly reading the ADC data from the ADC sample sequencer 3 FIFO data register. Since the ADC is continuously taking the data and providing the results, so we just need to read the result from this FIFO data register. Next to the FIFO data register, we are calculating the temperature value by the formula as we discussed earlier. Since we are using 4-digit 7-segment display, therefore we need to break down the temperature value into 4 different digits. This line of code is doing the same. So this line of code is sending those 4 digits one by one on the 7-segment display. So this while loop execute continuously. We are reading the data, we are converting into some array, and we are displaying those array elements to the 7-segment display. And at the end of the code, you can see the definition of the delay function that we are using to generate the delay in the program. So that's all the C language program that we have written for showing the temperature on 7-segment display by reading the LM35 temperature sensor. Now let's build this project and see if there are any errors. So you can see the project has been successfully built. There are no errors, and .ax file has been generated successfully. The next step is to select the stylus ICDI in the debug menu, because in TIVA-C series Launchpad we have this debugger and programmer. Hit OK. Now connect your TIVA-C series Launchpad with the computer. So by default, Blinky is loaded in this microcontroller. Hit the load button, and you can see the microcontroller has been programmed successfully. Press the reset button, and you can see the LM35 temperature sensor showing the room temperature is 35 degrees centigrade. So that was all about the analog interfacing with the TIVA-C series Launchpad microcontroller. So in this video, we discussed temperature measurement system using LM35 temperature sensor and 4-digit 7-segment display of anode type. I hope it was helpful for you. If you have any question, please feel free to ask. Thank you. See you next time.